This part of the question was actually I couldn't record. There was some error in the recording, so I'm recording again. So this is the question. Here, the question is, let me quickly do this question. So here, the general transport equation is given, and we have to uh, determine what is this term phi or mass conservation. So if this is a volume, say delta V, and there are some particle are entering here and some particle are leaving with respect to time, and the density of the particles we are interested in, let's say rho, and mass of the particles are m. So this mass can be mn star, or I mean it can be electron or holes. Okay. Now the number of particles, the particle density that are changing inside the volume with respect to time, that will be del rho by del t, and we'll multiply delta v because we are considering this volume. That will be actually equal to the particles which are coming inside this volume and going out. So if the number of particles coming inside is more than the number of outgoing particles, then the total number of particles will increase with time. Okay. So this will be particle flux incoming minus outgoing. Okay. And this will also, there will be also a term for generation and recombination if there are excess carriers, for example, because of incident light, number of carriers will increase, so there may be a generation and recombination term, but for this case let's consider this is 0. Okay. Or 1 can be anything, there can be some generation and recombination. Okay. And this term will also be multiplied with delta V. We are considering the whole volume. So this gets cancelled out, and how the particle density or the number of particles are changing inside this volume will be given by this expression. So here you can see only, you can look at only the first term, del rho phi by del t, that is the change in the number of particles. So how the particles density is changing. So for mass conservation, we don't have to separately consider the parameter phi, because that is already being considered in the transport equation. So therefore phi is equal to 1 for mass conservation. Okay. So here the answer is answer is C, which is 1. Okay, I already discussed in this question in the live session, but because of the error in the recording, I'm recording the last question again.